Omega. So there's the URL, here's the input form, help and documentation if you want to look through it. You're first going to set what kind of sequence you've got, and this will sometimes appear in a small box in a different place, but it does the same thing. And so I'm going to paste in some proteins, but it can align any of those. So here's a couple proteins. Now this is not going to work because these proteins are not in FASTA format. So let's make them FASTA format by setting the title line with a greater than character on it. And then go down here. And so you can set your output format. So this is fine for just seeing how two things are related. If you need the files, rather the sequences to be aligned with the correct gapping, but you need each one to be separate, not sort of intermixed with each other, then you want something like a Pearson FASTA, and all these others are options for different things. Click more options if you want. So de-align will take out any gaps that are in your sequences to start, and we'll leave that off for now. There are different guide trees and iterations that it can do, and so generally leave those on. If you have a tree that's going to be a problem, you can set it to do more iterations. So this is the number of combined iterations, combination of guide tree and hidden Markov model iterations. And so if we have 5 combined and I want to iterate both halves of this, I'm going to say about half on each one. Distance matrix, I don't think we need for this one, etc. So there we go. And so we can hit submit, but instead of doing that, let's just go to the results, which I have over here. Results will look like this. You got a couple of results tabs. And so the results alignments, rather, are what it's going to show. And so here again, this is your 2 sequences, and it's showing them on lines. So this first one comes up to here, and then after this I, number 60, it goes over there. So this V is number 61 in that sequence, and that's all it's doing. For this particular one, after this dash, which means nothing, this dash will be the next one in the sequence. So that's how you're reading it. It's the 2 alignments going kind of one on top of the other and broken up so that you can see it on the screen. Okay, let's look at this other way. So on the results summary page, you've got several things you can look at. You can see your input sequences. There they are, looking great. You can see the output. We already saw that. You can see the alignment in Clustal format, which is what we were just looking at. You can get your phylogenetic tree. So this would be able to be placed into a tree browser, and you'd be able to see that. I think that's a Newick format. Percent identity matrix is comparing the 2. So this is comparing Henosepilacna. And so these 2, 1 and 2, are in this position here. That's 1 versus 1. And so it's 100% identical to itself, only 35% identical to the second one, WIV19. So there you go. And so basically it's going to be mirrored either side of a diagonal line here, because this is 2 versus 1 and that's 1 versus 2. And the way they're calculating this, there is no difference between those two. So it's not like a matrix operation where that might actually make a difference. All right, fine. Let's go back. Here we go. What else have we got? Phylogenetic tree. There we go. We only put in 2 things, so it's not much of a tree, but you can show it in cladogram style, which is every step having the same length, or real style, where the length is proportionate to the amount of evolution that has happened between those things. You've got different results viewers here. So gel view is quite nice, although I think it may make you launch that manually, but it's a very nice way to view sequences. And then submission details are some sort of stats and things if you need that. So there you go. That's what you ran, how you ran it, and how you can look at this. And so what you'll see here is that you do not have, for the most part, statistics. You can dig into some of these files and get some stats out. But for the most part, when we're using Clustal Omega, we are just making the best alignment that can be made, and we're just going to trust that it's the best alignment that can be made. It will align 2 things the best it can. It's your job to make sure those two things are homologous. Otherwise, everything that Clustal Omega does is basically a lie, because you can align two different things, and Clustal Omega will do its best to do that. But if you're not supposed to align them because they do not share a common ancestor, then you are just doing things and not doing things for a reason. That's what I would say. All right, there you go.